You may have heard about a NASA probe that yesterday successfully brought back to Earth some samples from a deep space asteroid. It took 4 billion miles to get them, but researchers believe it'll be worth it. You may also be wondering just why scientists want these samples from what's essentially a huge rock flying through space. Well, Miles O'Brien is here to explain.
CDL milestone, we have confirmed parachute deployment.
It looked like one of those nail-biting rover landings on Mars. But the team in this mission control is savoring a safe arrival on this planet of some precious pieces of an asteroid. The Utah Test and Training Range was the final stop on a 7-year mission to harvest a payload of rock and gravel, so-called regolith, from the surface of an asteroid named Bennu.
Then we heard main chute detected, and I literally broke into tears. And I'm probably going to do it right now just thinking about it, because that was the moment I knew we made it home.
University of Arizona planetary scientist Dante Lauretta is the principal investigator for OSIRIS-REx.
And then these up here are the actual images that we acquired on the spacecraft.
I first met him 2 years after launch, when the spacecraft was homing in on Bennu. I caught up with him again a few weeks ago.
Bennu is a very rare type of asteroid in the inner solar system. It's incredibly dark, darker than asphalt, and we believed that that meant it was rich in carbon, which is the essential element for all life on Earth and key to our origins investigation.
Origins, as in the origins of life on Earth. Asteroids are rocks left over from the formation of the solar system 4.5 billion years ago, orbiting in the deep freeze of space ever since. Anything mixed in, like water or organic chemicals, likely remains pristine. Earth, on the other hand, is a geologically active place. In its early days, it was made up almost entirely of magma, not a cushy berth for life. But what if vast swarms of asteroids, like Bennu, bombarded Earth just as it was cooling down, say, about 4 billion years ago?
We believe they delivered the compounds that are essential to making the Earth a habitable world. The water that's in our oceans, the air that's in our atmosphere, and the organic material that makes up our bodies and all life forms on Earth.
That's what makes Lauretta and the team so excited about bringing some asteroid regolith to Earth. They cooked up a creative approach to collecting the sample, the touch-and-go method, kind of like a pogo stick.
Just make a brief, maybe 5-second contact, scoop up as much material as you can, and then back away with that treasure safely in hand.
The Bennu Bonanza is destined for hallowed ground in the world of space retrieval missions. NASA's Johnson Space Center, the keeper of the Apollo moon rocks. Bennu's regolith will reside nearby. Scientists are anxious to get busy running the rocks through a gauntlet of tests. They've done several dress rehearsals to get ready. They dress for a raging pandemic. But why? Perhaps life might imitate art.
These people were cut down in mid-stride.
Everybody's dead! No!
In the 1971 film The Andromeda Strain, a satellite crashes in New Mexico and infects Earth with a virulent extraterrestrial pathogen, killing nearly everyone who comes in contact with it. Great science fiction, but
the science fact of it is that it's a very low risk for Earth.
Elaine Seasley is NASA's Deputy Planetary Protection Officer. And yes, that is a real job. Her office is on a mission to ensure extraterrestrial rocks don't unleash uncontrollable harm to Earth and its inhabitants.
Most of our missions that explore the solar system are doing so in an unrestricted manner. So we can bring back samples from asteroids, samples from comets, solar winds, those types of particles. All of those don't have a risk of biological contamination.
Researchers say it's all but impossible that anything is alive on a small asteroid, which is bathed in deadly doses of radiation from the sun. Seasley says the main reason scientists need to suit up and do their work in a clean room is to protect it from us.
This is a case where Earth could potentially contaminate the samples once it lands, and so that's why there's special protocols and special handling procedures in place to try to maintain the cleanliness of the samples through that delicate handling process.
Bennu's rocks may be low risk, But the asteroid itself is a potential threat to Earth, a so-called near-Earth object. Astronomers say it's on course to whiz between us and the moon in 2135, and perhaps paint a bullseye on us in 2182. While NASA monitors that threat, interplanetary contamination garners more attention as the agency aims to grab and return rocks from the moon and Mars.
When we bring these samples back, we are going to keep them very, very well protected until we have assured ourselves that the samples are safe.
Lori Glaze is NASA's Planetary Science Division Director. She heads the team at NASA that, along with the European Space Agency, is planning a mission to retrieve and return rocks from Mars in the next decade. The first phase of the mission is underway. NASA's Perseverance rover has been gathering and sealing up small pieces of the Martian surface for a few years. Planetary scientists think its location, the Jezero crater, was warm and wet 3.5 billion years ago, a great place to search for signs of ancient life. But they don't expect to find anything that's alive now.
The current environment on the surface of Mars is incredibly harsh. It's cold, it's dry, it is exposed to the sun's radiation, which we know kills off organic materials and breaks it down. So it's highly unlikely that there's anything alive there now, but what we might see is the kind of fossil remnants of early microbes and pre-microbial life.
A Mars sample return mission is the holy grail for scientists like Dante Loretta. He says it's all well worth any slim risk akin to the Andromeda strain.
Finding life on Mars, especially an independent origin of life, would be one of the most profound scientific discoveries in human history. It would be as important as when Copernicus showed us that the Earth was not the center of the universe and that, in fact, the Earth revolved around the sun. It's that huge of a mind shift because all of a sudden it's like two planets, one system, both had the origin of life. Life has to be everywhere.
And maybe the best messengers of the ingredients of life were asteroids. Bennu might help unlock that secret once scientists begin their careful work, equal parts probing and protecting. For the PBS NewsHour, I'm Miles O'Brien.